In this video, we will discuss about laws of thermodynamics. In the basically physics, in every action, it will be having some type of principles or law. For example, here is a thermodynamics. It is starting it's from the equation of energy. First, we have to derive the principle of thermodynamics. It says that some type of fuel it's converted into mechanical energy and finally it's converted into electrical energy. This is the principle of thermodynamics. But here we incorporated in this principle incorporated in the 4 laws of thermodynamics. So from these we have to first focus upon the 0th law of thermodynamics. So 0th law of thermodynamics means it is focused or it's tell about the state of a thermal equilibrium. For example, consider any two type of object, it will be having a same or higher or lower amount of thermal equilibrium. It will be same two passes to the third one of the system. So this is the 0th law of thermodynamics. For example, these two objects considered as A and object B, both it will be in having a similar contact in between them. But the third object it will be located in the same. It will be also having the thermal equilibrium of the same. So this is the concept of 0th law of thermodynamics. And next we have to focus upon first law of thermodynamics. So first law of thermodynamics states that there is a integral of Q is equal to integral of W. It means the total net heat transfer is equivalent to the total work done. Basically we see that about work done means it is a inlet minus outlet. But here it will be the first law says about this is the Q means this is the total heat transfer and work done means it is the total work done. So the first law says about that the net heat transfer it is equivalent to the net work done. Next we have to focus upon second law of thermodynamics. Here the second law of thermodynamics if the two scientists will state the statement, they called as a scientist name of Clausius statement and another one is a Kelvin Planck statement. So here the second law of thermodynamics, the Clausius will says about that in every engine it will be working under the conditions of hot reservoir section and cold reservoir section. That is impossible to construct on any type of engine without external aid or without the rejection part. And another one is will quoted about the statement of if we are applying some amount of energy is the inlet, surely it will be having the some amount of energy loss in the exit section. So there is impossible to construct an engine without possessing or without crashing of resource section. So it is the quoted about the second law of thermodynamics. And the next we have to focus upon third law of entropy. So the third law of entropy it is fully focused upon the entropy section. So here the third law of entropy in the pure substance it will be having the amount of entropy, it will be affecting the heat transfer phenomenon and thermal pressure variations and internal energy, the all conditions also. So the final third law is quoted about the fully statement of entropy concept, and that these 3 laws are fully incorporated in Aero engine thermodynamics. And further these laws will potential or will apply to the any type of mechanical engine operating or any physical phenomena. Rather than this type of cycle, the closed systems and open systems are also working this. Under this category, the another portion is the steady flow energy equation. It is quoted or it is mentioned about within the prior of this class. So these are the four laws which have fully incorporated in aero engineering thermodynamics.